Hello, in this video you will see how to control DC motors of DaNI robots. Here you can see the basic functions that you can apply to your robotic systems. You have some functions for starting robot, writing speed to DC motors, read speed from DC motors, write servo angle, read ping sensor distance, and at the end to close your drivers. The goal of this experiment is to give basic instruction on how to control DC motors. Controlling motors, your robot will move around. DC motors are connected to appropriate drivers that deliver the required power supply and control signal to them. Pulse width modulation, or PWM, is a technique in which a series of digital pulses is used to control an analog circuit. The length and frequency of these pulses determine the total power delivered to the circuit. PWM signals are most commonly used to control DC motors, but have many other applications, from controlling wells or pumps to adjusting the brightness of an LED. A digital pulse train that makes up so we use the PWM signal with fixed frequency and varies the pulse width to alter the average power of the signal. The rating of the pulse width to the period is referred to the duty cycle of the signal. For example, if a PWM signal has a 10 milliseconds period and its pulse are 2 milliseconds long, the signal is said to have a 20% duty cycle. As shown on the left figure, we see a duty cycle of 25, 75 and 50%. Okay, now we will open lab view. Okay, open your lab views. So okay, open your lab view and click on a button create new project. Go to Robotics tab and click Robotics Project Templates. Now we will choose Robotics Environment Simulator because all of code that we run on the simulator will work also on Robotics Starter Kit 0.2 robot. So go to Robotic Environment Simulator. And now you will see that we have robotics scene load like this, and that we use our starter kit 2.0 robot with parallax ping sonar. You can change environments here or robot, add some sensors and design maybe your own obstacles to environment, but we will use this basic environment now and our DaNI robot. Click next. Give your project name experiment 1 and click button save. Now our project is open And you can see here under the robotics environment simulator that we have some XML, some TXT and VI files. Go to a VI file, open it, and it will open block diagram front panel like this. If you now press run button, the program starts and you can see here your environment from your simulation, and here is the robot. Now he just stand there because we didn't implement any of algorithms. So I will stop program. You can see here the also simulated environment is closed, and now open a block diagram. So here is the template for our code. These functions here on the left side used for initializing simulator environment. So this is something that you just stand there and we do not change anything. For this experiment, because it's a really simple one, I suggest to delete this event structure and just reconnect your error line. So that, and because there was in event structure a stop button, we will just add a new stop button from a boolean palette. So stop button. Okay, I will just move this here. So now we want, okay, just to connect the stop button, move it to a while loop, and connect to a broken line. Okay. So as I said, we would like to control speed of DC motors in this exercise, and what we need to achieve that, we need some slider to control the speed of motor, and we need one waveform chart to see what is going on a real system. I will enlarge this retype here motor RPM and rescale from -100 to 100. Also, this slider we will enlarge and rescale also from -100 to 100. Okay. So with the slider we will controlling the speed of motor, and on this waveform chart we will looking what is achieved motor speed. So just to put these things inside the loop, we don't want to look them as an icon because of the space. And now we need to see how to send the data to a real robot. First, we need to initialize the drivers, and here we want to set the type of our robot. Right click, and from function palette go to robotics starter kit 2.0, and I will pin for now this palette. And because we are using simulated environment, we just use this initialize sim. If you are using or you want to use this code to your real robot, you will use just normal initialize block. This block we need to connect it with error signal, so I will connect it like this. And the other is robot ID. We will create constant, and it's automatically puts what it needs. So starter kit 2.0 robot. Okay, now with this slider we want to control or write down the motor velocity. I will put it here. Also, what we need to start hit host in line, so connect it, and now we need to connect error signal. Okay, we also have here right motor velocity in radians per second and left motor velocity in radians per second, and we want to control the motor speed in rotation per minute. So we want to control motor speed in rotation per minute, and this function block will accept only radians in second, and we'll now search for RPM to radians per second VI, so RPM per second. Because we have two motors, we will use two of these blocks, connect it, and now, because of motor orientation, one of them we need to multiply by -1, and we will, so we don't actually need to okay, now connect right motor to this line, and we need to connect left motor also, and because of the geometry of the robot, from numeric palette we use negative block to multiply this motor speed by -1 in order to achieve the straight movement of robot. When we send these speeds to robot, we would like to read what's going on, and in order to do that, we now go to started kit 0.2 palette, and from that palette we use read DC motor velocities. Connect error signal, connect host signal, again connect error here to status, okay, and reconnect this. Now we have from this block robot speed in radian per seconds, and I will just use search again and now use radians per seconds to RPM VI. Okay. I will have two of them, and because we here multiply one speed left speed by -1, also but I realize that just we will change this, okay, delete and put it on the another wheel. Yeah, like that. Now we will connect left wheel here and the right wheel on the bottom one, and just change a little this equation, add a -1 before everything. Yeah, like that. Now we have a RPM speed of both motors, because it's information that we are collecting from the sensors. We would like to put some NF filter, so I will use just basic mean filter with 10 steps. Search mean point by point, and I will use now without connection here. So one going there and one there. Create constant with 10 points. Also connect here. And we want to look both signals on the same waveform chart, and we need a bundle function. Bundle delete this, and now we have controlling the speed of motor and read what is happening. And at the end we need to close our drivers, so going to robotic palette and use close VI, connect it with error line and with host line. And now we are ready to start our program. Go to front panel, run simulation, and we now see our robot. And robot is moving slowly. Why we cannot see here something nice? It's because we use this while loop and we did not put anywhere the some delay, and this while loop is very fast now, so we will add wait until next millisecond multiply and connect it with constant and put there somewhere around 100. So now this loop will execute and wait until the 100 milliseconds and then go another turn. If we now click play, first to just put it on 0 and click play. So here is the simulator. You can see white and red lines that representing the speed of a robot, left and right wheel, and now as I'm turning the speed more on, robot going faster, 70 rpm, I just go on negative, robot going down. And that's the R experiment. So in this video you learn how to control the DaNI DC motors. Thank you for watching.